For number 12, we have the limit as x approaches 0 from the right of x raised to the 3x. So if you plug in 0, then you're actually going to get 0 raised to the 0. So this is one of our indeterminate forms, but we actually want to kind of get it into one of our other indeterminate forms so that we can use L'Hopital's rule. So anytime you have a variable raised to a variable, this process is going to be kind of similar. And I want to use logs. So before we do that, actually, though, I do want to define the original problem kind of differently. I'm actually going to give it a name. I'm going to call it y. So y is equal to the limit as x approaches 0 of x to the 3x. This is going to make our life a little bit easier to actually give it the name y. Okay, so I want to take the logarithm or the ln of both sides. And the reason why I'm taking the logarithm of both sides is because we are able to bring down the power. And it's not a derivative thing. It's not because of the derivative. It's because of logarithms. You're just allowed to bring down the exponent. So this will be ln of y is equal to the limit as x approaches 0. And this is of 3x times ln of x. So if you plug in 0, then you're going to get, this is equal to 0 times negative infinity. If you approach 0 from the right of ln of 0, then you'll get negative infinity. So when it's this form, we actually want to rewrite it similar to how we did on some of the previous problems. So we keep getting these indeterminate forms, but we don't want to keep them in that particular indeterminate form. So I'm going to rewrite it as ln of y is equal to the limit as x approaches 0. And I'm going to rewrite this as ln of x over 1 over 3x. Now this seems kind of odd. Why would we do this? And I'll talk a little bit more about, well, let's talk about it right now. Anytime you have like two things being multiplied, so like 7 times 8, this is equivalent to 8 divided by 1 over 7. So anytime you're multiplying by something, you can divide by the reciprocal of that, and it's actually the same thing. So that's why we're transforming, or I should say that's how we're transforming. I wonder if you can hear the dog in the background. I always try to make these videos, or try to get the background noise as quiet as possible, but sometimes I can't. Anyway, so instead of writing it as 3x times ln of x, this is ln of x over 1 over 3x. So if I do that, or if it's in that form now, and you plug in 0, then this is going to be equal to, whoops, I used the eraser. There we go. So then that's going to be equal to negative infinity over infinity. So because it's in this form, now I can use L'Hopital's rule. So if you use L'Hopital's rule, then ln of y is equal to the limit as x goes to 0 of 1 over x, and this will be negative 1/3 x to the negative 2. I do want to rewrite this, so a lot of rewriting on this problem. So 1 over x, and I'm going to call that negative 1 over 3x to the positive 2. This is equal to 1 over x times, I can take the reciprocal, negative 3x squared over 1, and then one of those x's will cancel out, and I'm left with negative 3x. So this is a rewriting step here. So my problem has become the ln of y is equal to the limit as x approaches 0, and this is of negative 3x. So if you plug in the 0 finally, then ln of y is just equal to 0. And we're not quite done yet because we are solving for y, not ln of y. So I am going to rewrite it as log base e of y is equal to 0. And I'm doing this because now I can transform it. So e raised to the 0 is equal to y, or we can say y is equal to 1. So after all that, after all of the rewriting and L'Hopital rule, it's equal to 1.